Combustion reactions follow the most consistent pattern of all 5 types of chemical reactions, but they are also the type that students most often forget about. Since they're so simple, a lot of students see them and immediately miscategorize them as a double replacement reaction or a synthesis reaction, or most often a single replacement reaction. But they are none of those. Combustion reactions follow their own special pattern, and it's actually the most recognizable type of reaction of all of them, if you know what you're looking for. Combustion reactions are the only type of chemical reaction that start with one compound and one element, and end with 2 compounds. This is always true, at least as far as our class is concerned. But there's something even more recognizable about combustion reactions. Take a look at the elements shown here on the screen. All you see are C's, H's, and O's, carbons, hydrogens, and oxygens. That's because these are the only elements, for the most part, that ever participate in combustion reactions. It's true. Most of the time, combustion reactions only include carbon, hydrogen, and oxygen atoms. This is the easiest way to recognize them, and it gets even easier because those carbons, hydrogens, and oxygens always fall into the same order in the reaction. Here's what I mean. First of all, the products are always going to be exactly the same. No, it doesn't matter whether the CO2 or the H2O comes first, but they will always be the only products in a combustion reaction. Combustion reactions always produce carbon dioxide and water. Always. No guessing, no tricky patterns, none of that. It's always CO2 and H2O on the product side. The reactant side is simple, but there's one thing that changes from reaction to reaction. All combustion reactions require O2, oxygen gas. Combustion cannot happen without oxygen present. So, in every single combustion reaction, elemental oxygen, O2, is always going to be one of the 2 reactants. The other reactant, this CXHY thing, this is called a hydrocarbon. Hydrocarbons are a group of chemical compounds that are mainly made of carbon and hydrogen. They are particularly useful as fuels, like propane for a gas grill, or methane for heating our homes, or butane in a lighter. These are all hydrocarbons, compounds made of only carbon and hydrogen atoms that easily react with oxygen in combustion reactions. Sometimes hydrocarbons get a little more complicated, but we're never going to see that in our class. As far as we're concerned, hydrocarbons are fuel molecules made of all carbon and hydrogen. That's why it's shown here as CXHY. CH4, that's methane. It's also known as natural gas. C2H4, C4H6, C6H12, C10H22, and they get even bigger. But they are all hydrocarbons, carbon-hydrogen compounds that act like a fuel in combustion reactions. And they always show up on the reactant side of a combustion reaction. So combustion reactions always follow this same pattern: a hydrocarbon reacting with oxygen gas to form carbon dioxide and water. Same reactants, same products, every time. The tricky part is remembering how simple it is. Here's an example. Methane, CH4, is burned to produce energy for electricity in natural gas power plants. For this to happen, the methane reacts with oxygen gas, O2, to combust, forming the normal products of a combustion reaction, CO2 and H2O, carbon dioxide and water. The same thing happens when you flick on a lighter. Butane, C4H10, reacts with oxygen in the air around it to spark and burn. This produces carbon dioxide and water, just like every other combustion reaction. But what happens if we're missing some of this information? How can we write a chemical equation for a combustion reaction if we only know some of the pieces? Here's an example. Liquid ethane, C2H4, that's its chemical formula. is burned in open air. So what information have we been given here? We know we've got ethane as one of our reactants, and we've been given its formula, C2H4. And that statement says it burns. That has to mean combustion, right? But in order for combustion to take place, we need one more reactant. Here it is, open air. Combustion reactions rely on oxygen gas in the air around them to burn. So when we read open air, the statement is really trying to tell us oxygen. But how do we write this out as a chemical equation? Let's start with what we know. C2H4 is the formula for liquid ethane. That's our hydrocarbon. Another sign that this is definitely a combustion reaction. We started with a hydrocarbon. Remember that all combustion reactions need some sort of fuel in order to burn. Hydrocarbons are the fuel we will always use in this class. The ethene reacts with oxygen gas, O2, in the open air around it, so that it can actually burn. But what about the products? So far, we only have reactants. We know this is a combustion reaction because the word burned in the original statement, but it doesn't tell us anything about the products that are formed. Oh wait, this is a combustion reaction, and combustion reactions are the easiest of all because they always have the exact same products: carbon dioxide and water, CO2 and H2O. So, the correct equation for this chemical reaction is C2H4 plus O2 reacts to form CO2 and H2O. Here's another example. Try this one on your own. Pause the video, determine what the products will be, and then press play for the answer. Here we have heptane gas in a tank. We also have heptane's chemical formula, C7H16. We also see the words explodes and fire. Okay, sounds like a combustion reaction to me. So let's write out the equation. Heptane is our fuel. That's our hydrocarbon. Its formula is C7H16. We got that from the statement. We also see in order for the reaction to occur, we need another reactant. As always, oxygen gas must be present for any combustion reaction to occur. Even though the statement did not actually say anything about it, we know oxygen has to be involved on the reactant side. And for the products, those are the usual suspects as well: carbon dioxide and water, CO2 and H2O, as always. How did that go? Spend some time practicing predicting products of combustion reactions with the examples I've given you. The answers are also available so you can check your work.